we're going to look at estimation. Now, estimation is one of the key topics that throws you into hypothesis. Estimation and sampling usually go together. So I'll quickly talk about sampling, then go to estimation. So what is a sample? A sample is simply a small population, a small proportion of a population. The entire population is called a census. Component, a proportion of this is called a sample. And so sampling is very important for many reasons, mainly for costs, for time, for sufficiency of approximation, for accuracy levels as well. So we use a sample for these and many reasons. So population is called a what? A census. We have different types of sampling. We have what we call probability sampling methods and also non-probability sampling methods. Dealing with the probability sampling methods, we are dealing with numbers. Examples, we include a simple random sampling method where we pick numbers arbitrarily. This negates biasness. We also have a systematic kind of sampling method where we pick sampling units with a systematic number. For instance, every 10th, every 8th, every 20th, like we do the tithing, that's a systematic kind of sampling. Also use what we call stratified sampling. We also have what we call cluster sampling method, where we're going to put sampling units into common characteristics. For instance, top management, middle management, then we pick using a simple random sampling, any 5 to represent the whole group. Stratified is similar to cluster. We pick representations of different or similar characteristics. For instance, the Tongas alone, Bembas alone, then we pick representations. Non-probabilistic methods, we have several. We have convenience sampling method, where we pick respondents according to convenience. The positive sampling method, we pick, this is also called judgment-based method, where we pick respondents according to the information we have or purpose, in short. For instance, you want to ascertain the impact of polio on the health of children. So you can only possibly choose children who have had polio vaccines before. We also have snowball, which is one sampling method where we pick sampling units from a small to a bigger. The snow grows from small, it keeps growing and growing. This kind of sampling method is usually used when we are doing investigative kind of research. Exploratory, we can use a snowball. Who knows who. Now, as we do estimation, in sampling, we're going to use 2 categories, a proportion and a sample, standard deviation. So if you're looking for the sample size, Z squared, S squared over E squared. And when we're dealing with the proportion, Z squared PQ over E squared. E stands for the what? Level of precision or the error. The error comes in the term within. P is a proportion. P is 20%. The Q should be 80%. The Z is usually a 2-tailed undersampling, where we have our confidence levels, our significance levels, our alpha values, and our Z values. So if you've been in my class, I'm sure you know where these figures come from. We have 4 common levels of what? Confidence. Which ones are they? Number one, we have what are the common levels of confidence? 99,
98,
8, 95, and 90.
95, and 90.
95 and 90.
Symptoms levels, we have 1, 2, 5.
2, 5, and 10.
Alpha, we divide the level 900. Then when we go to what are our Z values here? 2.58. Then here, 3. Here, 1.96. Here, 1.645. Do you remember these? Then when we go to confidence interval for a single sample, when our Z by the way is used when our N is greater than 30. So here our formula is X plus minus what? Z alpha over 2, standard deviation, square root of N. Don't mind this Z over 2, everything has been done. This is our Z over 2. Right? This is for N greater than what? 30. If our N is less than 30, what we use? Our confidence interval would be, so confidence interval, mean plus minus alpha over 2 and N minus 1, and the standard deviation over the square root of N. For the proportion, our confidence interval is equal to P plus minus Z PQ over N square root of N, everything. Now, sometimes we have two samples. If we're dealing with two samples, our confidence interval will be a little bit long. We have the mean for sample 1, the mean for sample 2, then plus or minus Z alpha over 2. Then we are going to square root the variance for sample 1, and we add it to the variance for sample 2. Dealing with N greater than 30, that is. It's more tedious when you're dealing with N less than 30. Our formula becomes mean 1 minus mean 2. And here we're going to use a degree of freedom for two samples. So we're going to have N1 plus N2 minus 2. That is a degree of freedom. Then we're going to get what is called a put variance. This put variance is calculated separately. It has its own formula. This formula is kind of ugly. Something like that. Also, these formulas are given to you, so don't mind it so much. And moreover, he has not brought it in a long time. Anyway, let me get to simplifying your work. Suppose you're asked to find a 95% confidence interval, and we are told that the mean is 10 and your N is 49 and your standard deviation is 14. Find the confidence interval. So from our song, our Z at 95% is what? Who can remember? 1.96.
96.
So to calculate the confidence interval, who can tell us the formula? X bar plus minus Z. You can even leave out the alpha over 2. Sometimes it looks ugly. It may be simpler like this. Our mean is 10. Here put 1.96. Why are we using Z? Because the sample size is more than 30. So square root of 49. And our sample here is what? Standard deviation is 14. So square root of 49 is 7. And the 7, we divide it into the 14. We get a what? A 2. So we'll apply that 2. We're going to get our 3.9692. So whenever we're dealing with this, we first start by what? Subtracting 10 minus 3.92. We get what? 6.08. And here we add it, we get 13.92. And whenever we're commenting, we comment in terms of the what? Confidence level. So how do we comment? We are 95% confident that the true mean will lie between 6.08 and what? 13.92. Let's try. Suppose we're given a mean of 20 and we're given a variance of 144. Our n given is 100. We're asked to find a 99% confidence interval. Who wants to try to find a 99% confidence interval? Who wants to try to find a 99% confidence interval? So the formula is x bar plus minus z standard deviation over square root of n. Already we're given variance, so meaning our standard deviation here is what? 12. On the mean, we're going to put a 20 there. And the z, from our song, what is the z at 99%?
2.58.
The square root of 100. Right, so here we're going to write 20 plus or minus 2.58, and here we're going to multiply 1.2. So what do we get here? 20 plus minus what? Multiply these two, what are we getting? I don't have a calculator.
3.096.
0.96. Okay, and then you subtract and then you add. Sometimes you're given proportions to say we have 30%, our n is 50. Find a 90% confidence interval. So the formula is the proportion plus minus z n. Right, so our proportion is 0.3, meaning the remainder is 0.7. This will be our q. P is 0.3, q is 0.7. The two must add up to 100. So we're going to have 0.3 plus or minus. What's our z? What's our z? Our z would be what? If you're not given z, the standard is 5%, right? So we're going to put 1.96. And here we have 0.3 Here we have 0.7. Our n there be 50.
Isn't our Z 1.645?
Oh, even 1.645. So plus or minus 1.645, correct. Here 0.05. Okay, so when you compute it, what are we getting? Let me use arbitrary figures here. Suppose our answer here was what? 0.1. So when you subtract, this is 0.2. When we add, this is 0.4. So our comment is we are 90% confident that our true proportion will lie between 20% and 40%. We are 90% confident that our true proportion will lie between 20% and 40%. Whenever we're dealing with proportions, we will comment in terms of the proportion. Okay, so this is a 10-mark question that you need not to leave out. I'll take you to last year's exam question. So you see how easy these questions come. Confidence interval succinctly.
Mr. Collins.
I'll allow you to ask later. This question here, we have a random sample of 35 teenagers aged average 7.3. Okay, yes, suppose a random sample of 35 teenagers are average 7.3 hours of sleep per night. Assume standard deviation is 1.8. Find a 95% confidence interval and a 98% confidence interval. So in this question, it was carrying 10 marks. Cannot afford to leave out this question. So what are we given? Our n is 35, and this is our mean, 7.3, and our standard deviation is what? 1.8. So 95% confidence interval will mean our Z is what? Our Z will be what? At 95%. 1.96. Standard deviation is 1.8. Square root of n. N is 35. And compute it. At 98% confidence interval, we use the same parameters. The only difference is that at the Z instead of 1.96, what are we going to put? 2.33. Are we together? So you'll get the figures that are supposed to be there. Sometimes you may not be given a proportion. You can say out of a sample of 50, about 30 people showed interest. Find a 99% confidence interval.
Yes.
So for proportions, P, Z, PQ over N. So whenever I give given proportions, the proportion is simply a small sample over a big sample. 30 over 50 will give you 60% or 0.6. So meaning our Q will be 0.4. So in this case, we're going to have 0.6 plus minus. What is our Z at 99%? Z is
2.33.
Q will be 0.6. And our P will be 0.6, our Q will be 0.4. And here we pick the bigger sample size, which is 50. And there we know what to do next. So this is what we call our confidence interval. Now, if you're given a mean of 10, sample size is 16, and we have given standard deviation of 8. We are asked to find a 95% confidence interval. So quickly, you ask yourself, is my sample size greater than 30? Greater than 30, I'll use a Z. If it's less than 30, I'll use a T. Now, T is tricky because most people don't know how to read it. T is very easy to read. Step 1, you need to find your level of significance, which is 5%. Step 2, you are supposed to half it, which is 2.5%. And the degree of freedom is n minus 1, because we only have one sample here. So our n is 16, 16 minus 1 is 15. So how do we read the T table? We go to our statistical table and look for the values of T. It's the second table, and you're checking it from the Z. So when we go here, this is a Z, the following one is a T. So 5%, then half of 5% is what? 2.5, then n minus 1, where 16 minus 1 is 15. So you go here. So this is 1.131. So in this case here, 2.131. In this case, our confidence interval, it's the same formula, mean plus minus T, and standard deviation square root of n. So since our mean has been given, it's 10, plus minus the T is 2.131. Then our standard deviation is what? 8 square root of n. Our n is 16. Square root that one.
Mr. Collins, sorry, come again on the T table. I've seen the 15, but the other figure.
We're going to get a 2 there. So in this case, plus or minus 4.262. So you subtract and you add like that. So the T is only used when our n is less than 30. So how do you read the T again? You only need two things for the T: the level of significance and your n. So if our level of significance is what? 5%, our n is 16. So the degree of freedom for a single tail or a single sample is n minus 1. So this 16, when you subtract 1, we get a 15. And since the two-tailed test, we divide this by 2. It will be 2.5%. So other tables you need to check for 0.025. And you read under 15. So 5%, half of it is 2.5. Then you check under 15 there. 2.131. That is where we got the figure from. 2.131. That is where we got our figure from. Is that clear?
Yes.
Okay. Now, times when people stack this table that comes, how do I use this table? Say this is same as 2%, 2.5%, 0.025. You check under what? Under 15. It's the same. You need to acquaint yourself with how to read all the tables. So under 15, you're getting the same figure, 2.131. Are we together?
Yes.
So sometimes the examiner will just say 2, 4, 6, 8, 10. Find a 95% confidence interval. So in this case, he's trying to teach you how to go back to your statistics and calculate your mean and standard deviation on your own. In this case, we calculate our mean by doing what we do in statistics. So 2, 4, 6, 8, 10. Square this with 4, 16, 36, 64, and 100. Total here will be 30, summation of x. Total here will be 220, summation of x squared. If we go back to our topic 1, how do we find the mean? The mean is x bar is equal to summation of x over n. So 30, our n is 5, we got 5 units. So here we get our 6. So where there's mean, we put 6. The t, our n here is 5. Step 1 in reading the t, you do what? 5%, half of 5%, 2.5, n minus 1, n is 5, 5 minus 1 is 4. So when you go into the table, depending on the table you're using, 0.025 under what? Under 4, you get 2.776. So 2.776. Mr. Collins, how about if you're using the other table? Still the same answer is 2.5 under 5, then under 4, to get 2.776. Now, what does that thing mean? Because in class, the lecturer showed us something very long, n minus 1. This whole thing is a summary of what I'm teaching you here. Alpha over 2 is what we've divided, 5 over 2, or if you want 0.05 divided by 2, get 0.025. And how about this n minus 1? That is a degree of freedom. There are 5, 1, 2, 3, 4, 5. When you subtract 1, we get what? A 4. And what do? We go to the table and we read. This is where the figure is coming from, 0.025 under that. What mistakes do students make? They want to divide the answer again. That's why for me, I just put a t there. All right, then where do we get our standard deviation? We learned already in our statistics, our standard deviation. First find our variance, summation of x squared, summation of x to the power 2 over n, everything over n minus 1. So here we get 220 minus what? Minus 30 squared over 5, everything over 5 minus 1. This will give us 10. That is our variance. Our standard deviation is when you square root the variance, and this one is what will give us a 3.162. 3.162. This is what we put here, 3.162 over square root of what? N, which is 5. Mistakenly put, don't subtract the 1 from this, get the n itself here, right? So whatever follows, at least at that point, you're able to remember. All right, at this point, I'll ask for questions. Are there any questions? So this is how this is supposed to be done. This is how this question is supposed to be done. So I've sent you some homework already on the group. Beware of these questions that may come. I'm getting them from your QM Bible, or your exam will come from that. So you're given a table like this and you're asked to calculate a 95% confidence interval. Don't run to Z because the samples are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're only 10 and this is less than what? 30. So you calculate your mean, standard deviation, and also you read this from the T table. Are we together? Right, Mr. Collins. What happens if you're given two samples? Two samples, we're given sample A, sample B. Given the mean for sample A, it may be 20. Sample B is 10. The standard deviation here maybe is 5 and here is 3. The sample size here we are given 9 and here we're given 8. How do I find the confidence interval at 0.05? This is the toughest of it all. Or 2 samples. Let me start with something easier. Let me not confuse you. I'll go to that one later. It's all about formulas. All the formulas are given. The mean is what? 20, and here it is 10. Standard deviation here is 5, and here is 3. The n here is 40, and here is 30. And find at 5%. Okay. So since our n is greater than 30, don't even need to read in the table. At 5%, our z is what? 1.96. A sum comes in. But what is the formula for 2 samples? For 2 samples, simply mean 1 minus mean 2 plus or minus z. And here we have S1 squared over N1 plus S2 squared over N2. All right, so our mean one is 20. And here we have a 10. Then here we have plus or minus 1.96 from our sum. Then here we have our standard deviation, which is 5 squared over our n, which is 40. Plus or minus, no, this is plus, our standard deviation is 3 over n, which is what? 30. Here the absolute mean value is what? 10 plus or minus 1.96. You evaluate that, you're going to get a 2. 10 minus, you're going to have what? 3.92. You subtract, you're going to get 6.08. When you add, you're going to get 13.92. This is for 2 samples with a sample size greater than 30. But if the samples are less than 30, we have an ugly formula, ugliest, which I hope it doesn't come. So mean 1 minus mean 2. Plus or minus, we're going to have t. Then here we're going to have what is called the put variance. 1 over n1, 1 over n2. This is what the lecturer was trying to teach you today in the morning. Minus 10 plus or minus. Now, how do we read the t? Because these samples are less than 30. At 5%, half of 5% is what? 2.5%. But what is the degree of freedom for 2 samples? The degree of freedom is what? N1 plus N2 minus 2. So 8 plus 9, we get 17. 17 minus 2, we get 15. So these are 2 samples. So if you're going to read them, we're going to go to the table that we're reading, but we are going to subtract 2 from the total. So 17 minus 2 is 15. 5%, 2.5 at 15, 2.131. So here we're going to put 2.131. That is not the only headache. The other headache is here the sample for sample 1 is 9, sample size for sample 2 is 8. How do we find this put variance? This put variance has its own formula. This formula is given by n1 minus 1 plus n2 minus 1 and here we have n1 plus n2 minus 2. So we substitute all those figures in there to get the figure. I'll explain this tomorrow as we do our classes, but this is a formula. But listen, emphasize our exam is near. ANOVA is number 1 topic you need to learn. Regression is number 2 topic. I'm starting with the easiest one. Number 3 is what we're looking at. Hypothesis goes with estimation. Of course, you will not bring tough things. Then finally, statistics. Statistics takes a lot of your time, so do it last because you may spend 2 hours looking at it. Then I might touch some probability, but I don't want you to really be intimidated by probability. These 4 are enough for you to clear, not only to clear, but with an A. So today we did these 2. Tomorrow we're doing these 2. Then I'm done with you. Those who missed today's class, it was very interesting. I might repeat it for you guys. But hypothesis is what we're looking at right now, and statistics tomorrow. Also to look through exam type questions. All right. Any questions before I go? Any questions before I go? Maybe to look at this.
Can I ask something? I meant to ask in the MTP class, but I think I had a problem with network. So if you have a question that has got both production costs and administration costs, when calculating the break-even point, do you add the two fixed costs for both production and administration?
We'll look at that tomorrow.
All right.
Pertaining to this.
Mr. Collins, I wanted to ask on the T part where you got the 15, the last 15. You said N plus 1,
So if
N1 plus N2.
you add
Yes, right there.
minus 2,
This is N1 plus N2
minus 2. So 8.
minus 2.
Because from each one we are subtracting 1. From each one we are subtracting 1. So that's where the 2 is coming from. So 9.
Oh.
17. 17 minus 2, that's how we get the 15. If it was 1,
Oh, okay.
the N minus 1.
So it's N1 plus N2 minus 2.
Yes.
Okay. All right. Thank you.
Any other questions? All right. That being clarified.
You said ANOVA estimation, statistics, and what?
Okay, so ANOVA, regression, hypothesis, statistics. So these questions, we'll cover them, all of them tomorrow. Meeting me one day is enough to clear the exam because these are very easy. You don't need to boggle your mind about probability. So these are the easiest topics we ever experience. Okay. So
All right.
is anyone left behind? So tomorrow our schedule starts at 9 to 12. I will do 3 hours of each. 12 to 15. This is QM, ME. Then we're going to have 15 to 18 FMA. Then MTP, we're going to cover it in the evening and Monday morning. All right. So this is my schedule for you tomorrow. Carry packed lunch. We'll be doing a lot. So this will be a physical class. Online classes will also continue tomorrow. I'm sure everyone is now in camp, ready for battle. Thank you so much, everyone. Have a good night.